So hi guys, today we'll talk about building a transformer from scratch. So in this notebook we'll walk through how to build and train a transformer model from scratch for text classification. Rather than using pre-built model like BERT, GPT will implement a simpler version of transformer architecture to gain a deeper understanding of its core components. So the objective is to train a custom transformer model on a text classification dataset. So for that, we'll import all the required libraries, load our IMDb dataset, define vocabulary size, create a vectorization, add up the layer function to vectorize, prepare the train and train tested datasets, sample data check format. Then we'll build the transform model. For that, we'll define the transform block, build the complete model, apply transform blocks, add positional encoding, token embeddings, classification, everything. Then we'll compile the model and display model summary. This is the summary, and as you can see, all the layers uh, are displayed in this. Then we will move on to training and evaluating the transformer model. For this, we'll first define callback, then train the model and plot the graph. So this is the graph of model accuracy and model loss. Then we'll test with new examples. For that, we'll make a function named predict sentiment, and then a test examples. Just like this movie was absolutely fantastic, one of the best I've seen this year. Then get predictions and display results. So this movie was absolutely fantastic was a positive thing. That's why it gave prediction as positive. Then I hated is negative. So yes, model is working fine. Then yeah, we'll go to understanding the transformer architecture. We'll create a simple visualization of transformer architecture. See visualization. So this is model architecture, and we saved the PNG file of it, and we'll comparison of NLP approaches like pre-trained classifier, fine-tuned model, custom transformer. Now we will move on to fine-tuning pre-trained backbone. So for this, we have our objective that to pre-train. We'll take a pre-trained word model and fine-tune it on sentiment analysis dataset. So for that, we'll import our libraries, check versions, load the dataset, check sample, prepare the datasets, fine-tune the pre-trained word model. So for that, we'll define reversing layer per word, load of pre-trained word backbone for classification, compile the model and fine-tune the model. Then we'll plot the training history. As you can see, this is the graph of training accuracy and prediction accuracy, model accuracy during fine-tuning. Then we'll test the fine-tune model. So for the test examples, this movie was simply amazing. The plot twist kept me engaged throughout. These are different test examples. Then we'll predict using the fine-tuned model, display result, and evaluate on the test data. As you can see, we got the output. So the text is this movie was simply amazing. The plot twist kept me engaged throughout, and prediction is positive. That's true. Now we'll move on to inference with pre-trained classifier. For this pre-trained word classifier for sentiment analysis. So in this section, we load a small pre-trained word model that has been fine-tuned on the SSD sent for sentiment tree bank dataset for binary sentiment classification. For that, we will import all the required libraries. Then we will print TensorFlow version and Keras version. Then define some example, perform inference, and display results. So we got the result that this was negative and this was positive. Then we'll test the model uh, on different diverse examples. We'll get prediction, create simple visualization, and we'll plot a bar graph, bar chart. And as you can see, input and output, positive, negative, everything, and we got a bar chart as well, sentiment, prediction, confidence. Uh, so yes, this was um, building, fine tuning the model. Thank you so much for watching.